An idea that comes up in section 3.2 that we use a lot in this class is one that they call the empirical rule. Let's look at an example. Suppose our variable is weight of males in the United States. And let's suppose that the population mean, let's just suppose we know that. So again, this is information that typically we wouldn't know. It would be hard to know what all males in the United States weigh, but suppose that we do. And also suppose that we know the population standard deviation, the measurement of how much variability there is in the weight of every single male in the United States. And let's suppose that that is 10 pounds. I know a measure of the center of all these weights, and I know a measure of the variability of all these weights, and I could display these in a distribution. And if you graphed, like say, a little histogram of the weights of every male in the United States, what that histogram would look like is it might not be perfectly even. And so we're going to end up taking this sort of an idea and making a smooth curve out of it. This is going to represent the exact same idea that that histogram represents, but it turns out that when you do this sort of smoothing thing, that how the y-axis gets labeled is what we call density. And you can think about, we've taken all of these bars and kind of drawn a smooth curve over them, something like this. And so instead of drawing the individual bars, we just end up drawing the smooth curve. We're going to talk about for a second how the standard deviation comes into play with the picture. And how this works, you should draw what we're going to call one standard deviation above and below the mean. In order to make your picture as accurate as possible, those distances of one standard deviation above and below the mean are going to occur at what we call the point of inflection. I don't want to draw 160 being way down here or something like that. And then we would continue that pattern if we wanted to label more standard deviations above and below the mean. You can kind of think of the standard deviation as a unit like feet or inches. If you want to know how far something is from you, you can't say 3. You have to say 3 feet or 3 inches. And if we want to know how far 190 is above the mean, we are going to use standard deviation as a unit and talk about that value being 2 standard deviations above the mean, just like we could describe an object's distance being 2 feet from you. Let's look at what the empirical rule says. It says approximately 68% of the data will lie within 1 standard deviation from the mean. And then they just reiterate, they repeat that same exact idea. So again, the book will almost, it seems like it's making something more complicated by giving you some symbols like this, and you might say, oh, what is that talking about? We're talking about a number that is equivalent to being 1 standard deviation above the mean. So let's just look at our weight example again and how that applies to this variable. And so what this rule is saying is that approximately 68% of males will fall in this range. And that comes from the empirical rule. So that's most people. Most people weigh within 1 standard deviation of the mean. Again, you have to start thinking about standard deviation as a distance. It's kind of like saying most people live within 50 miles of a city. We're saying 68% of people weigh within 1 standard deviation of the mean. So not only does the empirical rule tell us a rule for what happens with values that are within 1 standard deviation of the mean. It also talks about values within 2 standard deviations of the mean. Within that range, I'm going to have 95% of males weigh within that range. And again, this is an approximation because I'm talking about this huge population. I'm talking about the weight of every male in the United States. Our population here is a huge number of people. You're going to have to use your imagination a bit and realize that in actuality, it's not very likely that we would know the population mean and the population standard deviation, because those are numbers that describe this entire group of individuals. But sometimes in this class, we will say, okay, assume that you do know the population mean and you do know the population standard deviation. Then if you did, what could you say about the weights of males? And if we go within 3 standard deviations of the mean, almost everybody is going to be within that range. I really don't think it makes sense to talk about approximately what's going on with our data, because our data is a group of numbers that we know everything about. I can figure out everything regarding what's going on with my data usually. I could use a computer program, even if I had millions of data points, I could figure out a range where most of my data is. What the empirical rule tells us is that if we go 3 standard deviations, that approximately 99.7% of everybody is going to fall within that range. So once again, this is the empirical rule telling us a fairly useful statement about a large group of individuals. We can talk about every single male in the United States and know a good idea of what proportion of them weigh between certain ranges. And that's pretty useful. That's a big shortcut to describing our population without measuring them. And here it is all summed up in one chart. Here we've got labeled in the middle. And again, this is not in any context. This is completely general. And they're just doing a little bit of math here. But if it's perfectly symmetric, then that means that if we have 68% in total within 1 standard deviation of the mean like this, then we could talk about how many are just, say, between the mean and 1 standard deviation above the mean and just dividing it by 2. And then they do that same sort of idea to talk about various intervals. And it might be worth spending a bit of time to think to yourself, where does this 13.5% come from? Where do these percentages come from? They all just come from a little bit of math. There's some subtraction involved and some division. You'll notice that these percentages are always the same because this is referring to the same exact region here. We're going to talk about this idea quite a bit more. We're going to use this idea quite a bit more. So as you use it, you should become more and more familiar with it. But just to summarize, the empirical rule tells us approximately what we expect to happen, meaning what proportion of our population is going to be within either 1 standard deviation of the mean, or 2 standard deviations of the mean, or 3 standard deviations of the mean.